Okay, so welcome to video number 3. This is going to be a Google Earth review of Latitude. So one of the challenges between drawing the diagram that we did on Thursday, the latitude diagram, and applying that to a globe is that you have to remember that we're dealing with going from a two-dimensional diagram to a three-dimensional globe. So doing something on the globe I thought might be fun, but it's really hard to put the globe up on the camera. So I came up with an idea of doing it on Google Earth. So this is Google Earth Pro. This is the Windows version. You have to have a Windows computer or a Mac computer to do Google Earth Pro. But again, it's a really powerful program. You can do a lot with it. I really recommend playing with it. All right, so here's what we're going to do. We're going to take the Earth, and you can, in Google Earth, we can move it around. We can look at the whole thing just like as if it was a regular globe. What I'm going to do is I'm going to run through a real quick review of Latitude. This doing, again, the same kind of logic steps that we did before on our diagram. The first thing I'm going to do, however, is I'm going to make the globe a little bit more plasticky. And that way we are going to be able to see the lines a little bit better. All right, so we have the globe. The next thing we're going to do is we're going to draw in the equator. So there's the equator. The equator is, again, a line that cuts the Earth in half. And that's going to be our beginning line. That's going to be our starting line. So that line right there is going to have a value of 0. Now, the next thing, when we do that, this is going to be the place where we measure from all the time. It's going to be our reference point. One of the things that you have to do in nearly every problem is think about where is the equator. All right, so the next thing that we did was we measured up to 15 degrees. And then we measured up to 30 degrees, and then we measured up to 40 degrees, and then 60 degrees, 75 degrees, and finally the North Pole at the top. So we drew additional isolines, additional parallels, to represent this increment, this interval of 15 degrees. Now, you'll notice that the lines look a little curved, but what we want to recognize is that they are parallel. If I spin the Earth here, those lines are never going to cross. As a matter of fact, I can look at them from the North Pole, and they look like this. They look like concentric circles. So again, they never cross. Now, this is an important thing to recognize right here, because if we look at the Earth from a weird perspective, like a tilted perspective, then what happens to those flat lines, those, remember, latitude, flatitude, well, remember what happens to those parallel lines is they still stay parallel. They're never going to cross, but they start to bend into these circles. So what we want to recognize is that when we make an inference, if we make an inference of what's between these two lines, we have to have our inference sort of curve along with the parallels. That's one important aspect of being able to think about the 3D version instead of the two-dimensional diagram. All right, so the next thing that we did, after doing the northern hemisphere parallels was we created the southern hemisphere parallels and the South Pole. So now we have, again, that same diagram of the Earth with the parallels, latitude, flatitude. The lines run flat, but they let us measure from the North Pole, or from the equator to the North Pole, or to the South Pole. All right, so that's a quick review of latitude in 3 dimensions. Remember that we're measuring from the equator at an angle to the parallel. And we can do that in any direction we want because we're only interested in going north or south. All right, so that's the review. That's the end of video number 3. So now if you have any questions or have any misconceptions or anything that you're confused about, send me an email so I can answer it and help you move on. All right, you can now go on to video number 4.